All right, we're still asked the graph, but I want you to notice that C is the vertex form of an equation, where A and B were the general form of equation. The vertex form of equation, it's actually much easier to determine the vertex in this. We can look at it. I went ahead and put the equation above it. This is our formula for the vertex form. And then you can look at it specifically and pull out your HK. So if H is going to be opposite of H, so it's going to be opposite here, so your vertex would be um, positive 3, and then it's the same as the K, so it's just going to be 2. So for when it's in the vertex form, it's going to be opposite, same to determine your vertex. Now when I come over here and make an XY table, it's easiest if I know my vertex in the middle right here because I know that from my formula, then it's probably nice and easy to pick numbers close to 3. So I would just say 2 and 1 and numbers bigger than our vertex, which is just 4 and 5. Now, I could pick the standard -2, -1, 0, 1, 2, but it might not give me a complete graph and I would just have to keep picking more points. If I know my vertex, if I'm able to, and I pick a couple points on each side of it, it's going to give me it's going to guarantee to give me a nice picture. Now we're going to do the exact same method that we did on the previous um, two problems. So I have 2x minus 3 squared plus 2. I write my function. Everywhere there is an x, I'm going to put a parenthesis. Okay, all I did is everywhere there was an x, I put a parenthesis. Now we're going to start with 1 and plug that in when x is 1. Okay, so then we would say, well, 1 minus 3 is -2 squared, and I carry everything down. -2 squared would be +4. I'm just going to carry everything down. 2 times 4 is 8. 8 plus 2 is 10. Going to do the same thing. This time we're going to let x equal 2. X equals 2. So then I have 2 minus 3 is going to be -1 squared. -1 squared is +1. 2 times 1 is 2 plus 2, which is going to give us 4. Now we already know our vertex because we pulled it from our formula that was given previously. We're going to work with 4 and then with 5. By substituting 4 in here, you're going to get x equals 4. I'm going to substitute a 4 in there and solve this. And for the sake of time, I just kind of did that in advance. You can pause it and copy the work if you need to see it. So 4 gave us a value of 4. And we'll do the same thing when we let x equals 5. So when we let x equal 5, we're going to plug a 5 in everywhere x is at and then solve this. And you can see here by the steps that we got 10 as well. So let's go plot these points on the graph. 110, it's about here, 2, 4, 3, 2, ordered pair 4, over 4, up 4, and the ordered pair over 5, up 10. We can see this is what our parabola looks like. Now we're going to name our domain, which is our leftmost x values, to our rightmost x values. And then the range is going to be the y value, so I'm on the y-axis. And the bottommost y value is going to be a 2. So we say bracket 2 to the topmost. Well, they're both arrows pointing up, so infinity. So you can see that although we had vertex form versus our original general form like we had for part B and C, we calculated the same way. With the vertex form, it is nice that we already know the vertex going into it, which our vertex is right here. or 3, 2. And it makes it easier to select some of our values for x. But other than that, you work them the exact same way. Alright, so we switch gears a little bit, and now they tell us to specifically graph by complete the square method. And we notice that a is equal to 1. So when this first number is a known 1, that's what that means. Your a term is equal to 1. What we're going to do is we write our function. And this is probably one of the least favorable methods, but we're going to take the time to go through it. I know you remember complete the square from circles. When we did our units on circles a few days ago, I want you to go back and look at that video to remind yourself about complete the square if you've forgotten. Some of the things are similar in completing the square for the circle, and some of them are different for when we're working with the parabola. So if you remember back for complete the square, the first thing we want to do is we want to have our x terms grouped together. Okay, and I'm just going to kind of ask this -5 right here to scoot over in a sense. Alright, I need to figure out what makes this a perfect square. So I'm trying to figure out what needs to go in this box. And we said always to determine the box for complete the square methods. It's the same for with circles. We take the b term, divide by 2, and square it. This is your a term, a known 1. So a is 1. This is your b term, b is 2. And this is your c term, in any quadratic. So when we're doing this box and we need the b term divided by 2, our b term in this case is going to be 2. So 2 divided by 2, and then we want to square it. Well, 2 divided by 2 is 1, and then 1 squared is just 1 times 1 is 1. Well, when I find out I put a 1 here, I can't just magically put a 1 here and throw my whole equation off balance. Well, here's my equal sign. Okay, if I just add a 1 on this side, I need to be able to undo that as well. So I'm going to subtract 1 on this side. So if I add 1 and I subtract 1 on the same side of the equal sign, I'm not changing the value. I'm changing the way it looks, but I'm not changing the value. Okay, this concept is a little bit different with circles. You can go back and look at that if you need to, but we're going to proceed through with parabolas. So if we have 1 here, we're going to subtract 1 to kind of cancel it out. Now, when we factor this, we can factor using bottoms up, or we can use our shortcut method, which is saying variable of the first, so we take x, sine of the second term, which is plus, square root of what's in our box, square root of 1 is 1, put it in parentheses and square it, and then I'm going to simplify. -5 minus 1 is going to be -6. We now see that we have our vertex form of our parabola, which if I pull those formulas in real quick, I can see that my h is going to be opposite of that. So it's going to be opposite of this, so it's -1. And my k is going to be whatever I have out here, which is -6. So my vertex is that hk. And I can name my vertex from here. So let me move this out of the way and let's go over and graph our vertex. So our vertex is -1, -6. -1, left 1, down 6. And now if I were to make my XY table, I have my vertex, -1, -6. So I'm going to put a dot by it because I know this is my vertex. I can pick values to the left of that and to the right of it. So to the left it's -1. I may want to just pick some values, 1 to the left, which is -2, and 1 to the right, which is 0, and then plug them in. Okay, so I'm going to come back over here and plug these in. Okay, so what I did was I moved everything out the way. I wrote my original function, and everywhere there's an x, I put a parenthesis because I'm going to start with letting x equal -2. -2, -2, using the same process as before. This is going to be +4. That becomes -4. 4 minus 4 is 0 minus 5 would give me -5. And then I'm also going to evaluate it at least one more time, and we're going to test it at x equals 0. 0 squared is 0. 2 times 0 is 0. Minus 5 is going to be negative 5. So we're going to go ahead and graph this. We know this is our vertex, and then negative 2, negative 5, and then 0, negative 5. And one more point would be nice to have to know where this graph crosses, which I went ahead and just plugged one in, which is 1, negative 2, and so we can make our parabola. The domain would be your left values, your x values left to right, and the range are going to be your y values, start from the bottom and go till you reach your graph, which is going to be negative 6 and then to infinity.